Assess part 2, question 2, the AQA question on page 209. Very straightforward. Triangle PQR, that's the bigger looking one, is an enlargement of triangle ABC with a scale factor of 5/4. Let's write it big so you can see it. So 5/4 is basically 1 1/4. So it's been enlarged by times 1 1/4. Right then, as you can see, since these shapes are similar, because one is the enlargement of the other, then the 110 degree angle there directly corresponds and is identical to the 110 degree angle there. Alright? Otherwise it wouldn't be a similar shape. Calculate RQ. Well, essentially the corresponding length of RQ is of course CB. So I'm going to take my 12 and multiply by 1 1/4. I'm going to use this top heavy fraction to make life easier. I'm working without a calculator, although I can, and check it out. Look, I can cancel down the 12 and the 4. 4 goes into himself once and goes into 12 3 times, and 3 5s are 15. Therefore the enlargement is 15 centimeters long. Nothing grade B there whatsoever. You're looking at top C's, low B's. And the last question. I thought this was very, very creative, very interesting, and so I chose to do this one. Let's go back to blue. Right, the diagram shows 3 mathematically similar containers. Right, similar shapes, so I can do some maths. Small, medium, large, look like polystyrene cups or something. Right, the table shows some info about these containers. Please note, not drawn accurately, so don't try to measure anything. Just go by the maths in the table and find the missing entries for X and Y. Alright? In other words, find out X and find out Y. Now, what have we got? I've got the height of the small one and the height of the medium one. I want the area of the small one, and I've been given the area of the medium one. So therefore I can use these 4 numbers to find the missing part X. Now, what do we got here? We've got a linear ratio, haven't we? So this is linear ratio, and the linear ratio of the small to the medium and that's going to be 12 of the small and 24 centimeter height of the medium. So I can simplify that. That's called 1 to 2, and that's lovely. Now look, we have a linear ratio here. We can upgrade, if you like, to get an area ratio and use these 2 facts to work out mystery X. Put a question mark there. So area ratio is going to be, take the linear ratio and you square it, don't you? And that's going to give us 1 to 4, and therefore if the medium one is actually 500 centimeters squared, we can now find the length of the smaller one by dividing by 4. Okay, so we're not enlarging from small to medium, we're shrinking down from medium to small. And since the larger one, the medium one in this case, is 4 times as big as the smaller one in terms of area, therefore I simply divide my 500 by 4, and that's going to give me 125 centimeters squares of area. Which part of the area? Yeah, the area of the top, so that's going to be like a flat circle, isn't it? So that's the area of that then. I think that's okay. 425s, yeah, that's good. That's that part done. Slide it down there. Hopefully we've got space to do this one. Right, what can we do? I've got to work out the volume of the largest one going. Now, what have I got? Let's work in red for a minute. I've got a linear ratio, in other words the 12 and the 36, and that's going to link in with the volume ratio of the 400 for the small one, and Y, the volume of the biggest cup that we've got. So I'm now working with that one and that one, aren't I? Alright, so let's just do the linear ratio working with small to large. So same again, small to large. Move over here a little bit. Is going to be 12 to 36, otherwise known as 1 to 3. Alright, that's the linear ratio. Now we're now going to work with volume ratio in order to upgrade to get the volume of the biggest cup here. Alright, that's meant to be a question mark. Right, volume ratio. is going to be the linear ratio cubed, isn't it? So 1 cubed is 1, 3 cubed is 27. So the big one is 27 times the volume of the baby one, isn't it? And the volume here is 400, and the volume here is, we don't know yet, but we're going to find out. So we're going to take our 400 and multiply by 27 times and get the volume of the big one in centimetres cubed. So therefore, volume of large container is going to be 400 centimetre cubes, or 400 millilitres, multiplied by 27. There it is there. Right, let's do that quickly. 400 multiplied by 27, and we've got ourselves, and this is incredible, 10,800 centimetres cubed of volume. There it is. 10,800 cm cubed. The little baby one was 400 cm cubed. Don't really care about that one. Don't have to work it out. Can do, don't want to. And that's very definitely grade A. It's a lovely way to finish the topic, and that's all I want to do with that. So, you know, study it. It's not a difficult topic. Now, obviously, playing with enlargements that go into negative scale factors, which are fractional, can be very awkward to draw. Certainly, pen and paper in exercise books, on graph paper, works. On screen, it's a complete pain. But hey, I've done the best job I can, and you'll do well to study this unit. This is Unit 14, Chapter 14, Enlargements, up to Grade A on the higher course. And it's Mr. C signing off right now.